The dim illumination of a switch and tester lights when the switch is in the off position suggests a small amount of current leaking through the circuit. This is likely due to capacitance between the switch and other wires, where wires in the electrical panel can have capacitance which allows a small amount of current to flow even when the circuit is open. Also, some electronic devices, even when turned off, can draw a small amount of current. When a radio is plugged in, it creates a parallel path for current to flow. This reduces the voltage drop across the switch, resulting in the switch light and tester lights illuminating correctly. To resolve the issue, you can try the following. Firstly, replace the switch. The switch may be defective or have a higher than normal leakage current, so replace it with a new, non-illuminated switch. Secondly, check the wiring to ensure that all wire connections are tight and secure, because loose connections can also cause leakage current. Thirdly, install a capacitor in parallel with the switch. This can reduce the voltage drop across the switch and prevent leakage current from reaching the switch light. Fourthly, use an LED bulb because LED bulbs draw very little current, which can minimize the leakage issue. If the problem persists even after these measures, it's recommended to consult with a qualified electrician to diagnose and resolve the issue. Capacitance in electrical wiring can cause unexpected behaviors in circuits, particularly with sensitive devices like illuminated switches and electronic testers. Understanding how capacitance arises and its effects can help troubleshoot these issues. Capacitance occurs when two conductors are separated by an insulating material, forming a capacitor. In electrical wiring, conductors are the wires themselves, and the insulation surrounding them acts as the dielectric. This configuration inadvertently creates capacitance between adjacent wires, especially in long runs or tightly packed wiring. The amount of capacitance depends on several factors, including the length of the parallel conductors, the distance between them, and the type of insulating material. Longer parallel runs and closer proximity increase capacitance, while different insulation materials have varying dielectric constants affecting the capacitance value. Even when a switch is open, this capacitance allows a small alternating current, AC, to flow through the circuit. At 120 volts alternating current, the capacitive reactance, which is the opposition to current flow due to capacitance, is high, limiting the current. However, it can be enough to dimly light an illuminated switch or trigger a sensitive tester. Illuminated switches often use a neon or LED indicator connected in parallel with the switch. These indicators require only a small current to light up. The capacitive current can provide this, causing the dim glow even when the switch is off. Similarly, electronic testers are designed to detect even small voltages or currents. The capacitive current can be sufficient to activate the tester, resulting in a false indication of a live circuit. Several methods can mitigate the effects of capacitance in these situations. Firstly, using shielded cables can reduce capacitance by providing a grounded conductive layer around the wires. This diverts capacitive current to ground, preventing it from affecting the circuit. Secondly, increasing the distance between wires can also decrease capacitance. This might involve reorganizing wiring runs or using spacers to maintain separation. Thirdly, adding a bleeder resistor in parallel with the indicator light or the device causing the issue can provide a path for the capacitive current to dissipate. The resistor value should be high enough to not significantly affect the circuit's normal operation, but low enough to bleed off the capacitive current. Fourthly, using LED bulbs with a very low current draw can reduce the impact of capacitive current. These bulbs require minimal current to light up, making them less susceptible to being activated by capacitive current. Diagnosing capacitance-related issues involves checking for voltage or current in the circuit when it should be off. A high-impedance multimeter can detect these small voltages or currents. Additionally, observing the behavior of illuminated switches or testers can provide clues. If the dim glow or false indication disappears when the load is disconnected, capacitance is likely the cause. In summary, capacitance in electrical wiring can cause unexpected behaviors such as dim lights in illuminated switches or false indications on electronic testers. Understanding the causes and effects of capacitance, along with implementing appropriate mitigation techniques, can help resolve these issues and ensure proper circuit operation. Electronic devices, even when turned off, can draw a small amount of current, contributing to the issue of dim lights in illuminated switches and false readings on circuit testers. This phenomenon is primarily due to the design and components within these devices, which can allow leakage current or phantom loads even when the device is in what appears to be an off state. Many electronic devices, such as televisions, computers, and chargers, use switching power supplies. These power supplies convert alternating current AC voltage to direct current DC voltage required by the device's internal components. Even when the device is turned off, the power supply may remain partially active, drawing a small amount of current to maintain standby functions or to be ready for remote activation. This standby power consumption is often referred to as a phantom load or vampire power. Some electronic devices have internal components, such as capacitors, that can store electrical charge. When the device is turned off, these capacitors may slowly discharge, creating a small current flow. This current can be sufficient to cause a dim glow in an illuminated switch or trigger a sensitive circuit tester. Devices with remote control capabilities often have a receiver that remains active even when the device is turned off. This receiver consumes a small amount of power to listen for signals from the remote control. This constant power draw contributes to the overall leakage current. Some devices may have internal circuits that are always powered, such as clocks or memory chips. These circuits require a continuous power supply to maintain their functions, resulting in a constant drain on the electrical system. The amount of current drawn by these electronic devices when turned off is typically small, often in the milliamp range. However, when combined with other factors such as capacitance in the wiring, it can be enough to cause noticeable effects in sensitive circuits. To mitigate the issue of leakage current from electronic devices, several strategies can be employed. Firstly, unplug devices when they are not in use. This completely disconnects the device from the power supply, eliminating any standby power consumption. Secondly, use power strips with switches to easily turn off multiple devices at once. This simplifies the process of cutting off power to devices that are not in use. Thirdly, choose energy-efficient devices that have lower standby power consumption. Look for devices with the Energy Star certification, which indicates that they meet certain energy efficiency standards. Fourthly, use smart plugs or smart power strips that can automatically turn off devices when they are not in use. These devices can be programmed to cut off power based on usage patterns or schedules. Diagnosing leakage current issues involves measuring the current flow in the circuit when the devices are turned off. A clamp meter can be used to measure the current without disconnecting the wires. If a significant current is detected, it indicates that one or more devices are drawing power even when turned off. In summary, electronic devices can draw a small amount of current even when turned off, due to standby power consumption, internal components, and remote control capabilities. This leakage current can contribute to the issue of dim lights in illuminated switches and false readings on circuit testers. By implementing strategies to reduce standby power consumption and carefully managing electronic devices, it is possible to minimize these effects and improve the overall efficiency of the electrical system. When a radio is plugged in, it creates a parallel path for current to flow, which can affect the behavior of illuminated switches and circuit testers in the circuit. This phenomenon is related to how current divides in parallel circuits and how the additional load affects the voltage drop across different components. In a typical circuit with an illuminated switch, the switch and its indicator light, such as a neon bulb or LED, are connected in series with the load, which in this case is a receptacle. When the switch is open, ideally, no current should flow through the circuit. However, due to factors like capacitance and leakage current, a small amount of current may still flow. This small current is often enough to cause the indicator light in the illuminated switch to glow dimly or trigger a sensitive circuit tester. When a radio is plugged into the receptacle, it creates a parallel path for current to flow. In a parallel circuit, the total current is divided among the different branches. The amount of current that flows through each branch depends on its impedance or resistance. The radio typically has a much lower impedance compared to the illuminated switch and its indicator light. As a result, most of the current will flow through the radio, which offers an easier path. This reduces the amount of current flowing through the illuminated switch and its indicator light. The voltage drop across the illuminated switch and its indicator light is proportional to the current flowing through them. When the radio is plugged in and drawing most of the current, the voltage drop across the illuminated switch decreases. This can cause the indicator light to glow more dimly or even turn off completely. Similarly, the circuit tester may no longer detect enough voltage or current to trigger its indicator lights. The effect of the radio on the illuminated switch and circuit tester depends on several factors, including firstly, the impedance of the radio. A lower impedance radio will draw more current and have a greater effect on the circuit. Secondly, the sensitivity of the indicator light in the illuminated switch. A more sensitive indicator light will be more easily affected by changes in current. Thirdly, the sensitivity of the circuit tester. A more sensitive circuit tester will be more likely to be triggered by small changes in voltage or current. To further illustrate this, consider a scenario where the illuminated switch has an indicator light that requires 1 mA to glow dimly. When the switch is open, capacitance and leakage current provide 0.8 mA, causing the light to glow dimly. When a radio with an impedance of 1200 ohms is plugged in, it draws 0.1 amps at 120 volts, which is much larger than the 0.8 mA flowing through the illuminated switch. As a result, the voltage drop across the switch decreases and the indicator light turns off. In summary, plugging in a radio creates a parallel path for current to flow, reducing the current and voltage drop across the illuminated switch and its indicator light. This can cause the indicator light to glow more dimly or turn off completely, and it can also affect the readings of a circuit tester. Understanding how current divides in parallel circuits and how the additional load affects the voltage drop across different components is essential for troubleshooting these types of issues. Replacing the switch is a common solution when troubleshooting issues with illuminated switches, especially when dealing with dim lights or unexpected behavior. The switch itself can be the source of the problem due to several factors, including firstly, defects in the switch. The switch may have internal defects, such as faulty components or damaged wiring, which can cause it to malfunction. These defects can lead to leakage current, incorrect readings, or intermittent operation. Secondly, higher than normal leakage current. Illuminated switches typically have a small amount of leakage current to power the indicator light. However, if the leakage current is higher than normal, it can cause the indicator light to glow dimly even when the switch is off. Thirdly, incompatible with the load. The switch may not be compatible with the type of load it is controlling. For example, some illuminated switches are not designed to work with certain types of LED bulbs or electronic devices. Fourthly, degradation over time. Switches can degrade over time due to wear and tear, exposure to heat, or other environmental factors. This degradation can lead to reduced performance, increased resistance, or other issues. When replacing the switch, it is important to choose a suitable replacement that is compatible with the circuit and the load. Consider the following factors. Firstly, switch type. Ensure that the replacement switch is the same type as the original switch, such as a single pole, double pole, or three-way switch. Secondly, voltage and current rating. The replacement switch should have a voltage and current rating that is equal to or greater than the original switch. Thirdly, compatibility with the load. Check that the replacement switch is compatible with the type of load it will be controlling, such as incandescent bulbs, LED bulbs, or electronic devices. Fourthly, quality and reliability. Choose a replacement switch from a reputable manufacturer to ensure quality and reliability. When installing the replacement switch, follow these steps. Firstly, turn off the power. Before working on any electrical circuit, turn off the power at the circuit breaker or fuse box. Secondly, disconnect the old switch. Carefully disconnect the wires from the old switch, noting their positions. Thirdly, connect the new switch. Connect the wires to the new switch in the same positions as they were connected to the old switch. Fourthly, test the new switch. Turn on the power and test the new switch to ensure that it is working properly. If the replacement switch does not solve the problem, There may be other issues in the circuit, such as faulty wiring or a problem with the load. In this case, it may be necessary to consult with a qualified electrician to diagnose and resolve the issue. In summary, replacing the switch is a common solution when troubleshooting issues with illuminated switches. The switch may be defective, have higher than normal leakage current, be incompatible with the load, or have degraded over time. When replacing the switch, it is important to choose a suitable replacement and follow proper installation procedures. Checking the wiring is a critical step in troubleshooting electrical issues, including problems with illuminated switches. Faulty or loose wiring can cause a variety of problems, such as dim lights, flickering lights, and even electrical hazards. When checking the wiring, it is important to look for several potential issues. Firstly, loose connections. Loose connections are a common cause of electrical problems. Over time, the screws or terminals that hold the wires in place can loosen, causing the wires to become disconnected or to make poor contact. Secondly, corroded connections. Corrosion can occur when wires are exposed to moisture or other corrosive substances. Corrosion can increase resistance and reduce the flow of current. Thirdly, damaged insulation. The insulation on wires can become damaged due to heat, age, or physical damage. Damaged insulation can expose the bare wires, creating a risk of short circuits or electrical shocks. Fourthly, incorrect wiring. Incorrect wiring can cause a variety of problems, including incorrect operation of the switch, short circuits, and electrical hazards. When checking the wiring, follow these steps. Firstly, turn off the power. Before working on any electrical circuit, turn off the power at the circuit breaker or fuse box. Secondly, inspect the connections. Carefully inspect the connections at the switch, the receptacle, and any other devices in the circuit. Look for loose wires, corroded terminals, and damaged insulation. Thirdly, tighten the connections. If you find any loose connections, tighten the screws or terminals to ensure that the wires are securely connected. Fourthly, repair or replace damaged wires. If you find any damaged wires, repair them with electrical tape or replace them with new wires. Fifthly, verify the wiring. Use a multimeter to verify that the wiring is correct. Check the voltage, current, and resistance of the circuit to ensure that it is operating properly. Some common wiring mistakes to watch out for. Firstly, incorrect polarity. Make sure that the hot, neutral, and ground wires are connected to the correct terminals. Secondly, open neutral. An open neutral can cause a variety of problems, including dim lights and flickering lights. Thirdly, ground faults. A ground fault occurs when a hot wire comes into contact with a grounded surface. This can cause a short circuit and an electrical shock hazard. If you are not comfortable checking the wiring yourself, it is best to consult with a qualified electrician. An electrician has the knowledge and experience to safely and effectively diagnose and repair electrical problems. In summary, checking the wiring is a critical step in troubleshooting electrical issues. Loose connections, corroded connections, damaged insulation, and incorrect wiring can all cause problems with illuminated switches. By carefully inspecting the wiring and making any necessary repairs, you can ensure that the circuit is operating safely and effectively. Installing a capacitor in parallel with the switch can be an effective solution for addressing issues such as dim lights in illuminated switches or false readings on circuit testers. A capacitor is an electrical component that stores energy in an electric field. When connected in parallel with a switch, it can help to reduce voltage fluctuations and stabilize the circuit. The basic principle behind using a capacitor in this way is that it acts as a buffer, storing energy when the voltage is high and releasing energy when the voltage is low. This helps to smooth out the voltage and reduce the effects of transient voltage spikes or dips. When the switch is open, a small amount of current may still flow through the circuit due to factors such as capacitance in the wiring or leakage current through electronic devices. This current can cause the indicator light in an illuminated switch to glow dimly or trigger a sensitive circuit tester. By installing a capacitor in parallel with the switch, the capacitor can absorb some of this current, reducing the voltage drop across the switch and preventing the indicator light from glowing or the tester from triggering. The choice of capacitor value is important. The capacitor should be large enough to effectively absorb the current, but not so large that it causes problems with the circuit. A typical value for this application is between 0.1 microfarads and 0.1 microfarads. The capacitor should also be rated for the appropriate voltage. In a 120 volts alternating current circuit, a capacitor with a voltage rating of at least 200 volts direct current is recommended. When installing the capacitor, follow these steps. Firstly, turn off the power. Before working on any electrical circuit, turn off the power at the circuit breaker or fuse box. Secondly, connect the capacitor. Connect the capacitor in parallel with the switch. This means connecting one lead of the capacitor to one terminal of the switch and the other lead of the capacitor to the other terminal of the switch. Thirdly, secure the connections. Make sure that the connections are secure and that the capacitor is properly insulated. Fourthly, test the circuit. Turn on the power and test the circuit to ensure that it is working properly. In some cases, it may be necessary to experiment with different capacitor values to find the optimal value for the circuit. If the capacitor is too small, it may not be effective in reducing the voltage drop. If the capacitor is too large, it may cause problems with the circuit, such as increased inrush current. It is important to note that installing a capacitor in parallel with a switch is not a substitute for addressing underlying wiring or circuit problems. If the circuit has faulty wiring or other issues, these problems should be addressed before installing a capacitor. In summary, installing a capacitor in parallel with the switch can be an effective solution for addressing issues such as dim lights in illuminated switches or false readings on circuit testers. The capacitor acts as a buffer, absorbing current and reducing voltage fluctuations. The choice of capacitor value is important, and it is important to follow proper installation procedures. Using an LED bulb can be a simple and effective solution to minimize leakage issues in circuits with illuminated switches. LED bulbs draw significantly less current compared to traditional incandescent or halogen bulbs. This lower current draw can reduce the impact of leakage current, which is often the cause of dim lights in illuminated switches when they are supposed to be off. When an illuminated switch is off, a small amount of current can still flow through the circuit due to factors like capacitance in the wiring or residual voltage. This small current is often enough to cause the indicator light in the switch to glow faintly even when the switch is in the off position. Since LED bulbs require very little current to operate, the leakage current is often insufficient to cause them to light up when the switch is off. This eliminates the dim glow issue and provides a more reliable off state. In addition to reducing leakage issues, LED bulbs offer several other benefits. Firstly, energy efficiency. LED bulbs are much more energy efficient than incandescent or halogen bulbs, using up to 80% less energy to produce the same amount of light. Secondly, long lifespan. LED bulbs have a much longer lifespan than traditional bulbs, lasting up to 25 times longer. Thirdly, low heat output. LED bulbs produce very little heat, which can help to reduce energy costs and improve safety. When selecting an LED bulb for use with an illuminated switch, it is important to choose a bulb that is compatible with the switch. Some illuminated switches are not designed to work with LED bulbs, and using an incompatible bulb can cause problems. Firstly, check the switch specifications. Before installing an LED bulb, check the specifications of the illuminated switch to ensure that it is compatible with LED bulbs. Secondly, choose a dimmable LED bulb. If the switch is a dimmer switch, choose a dimmable LED bulb that is specifically designed for use with dimmer switches. Thirdly, test the bulb. After installing the LED bulb, test the switch to ensure that it is working properly. If the bulb flickers or does not turn on, it may not be compatible with the switch. In some cases, it may be necessary to replace the illuminated switch with a switch that is specifically designed for use with LED bulbs. These switches typically have a low minimum load requirement, which makes them more compatible with the low current draw of LED bulbs. In summary, using an LED bulb can be a simple and effective solution to minimize leakage issues in circuits with illuminated switches. LED bulbs draw significantly less current compared to traditional bulbs, which can reduce the impact of leakage current and eliminate the dim glow issue. When selecting an LED bulb, it is important to choose a bulb that is compatible with the switch. Consulting with a qualified electrician is recommended when troubleshooting persistent electrical issues, especially when dealing with problems such as dim lights and illuminated switches that cannot be resolved through basic troubleshooting steps. A qualified electrician has the knowledge, experience, and tools to diagnose and repair complex electrical problems safely and effectively. Firstly, safety. Working with electricity can be dangerous, and it is important to take precautions to avoid electrical shock or other hazards. An electrician is trained to work safely with electricity and to follow all applicable safety codes and regulations. Secondly, expertise. Electricians have extensive knowledge of electrical systems and components, including wiring, switches, receptacles, circuit breakers, and lighting fixtures. They can quickly diagnose electrical problems and identify the underlying causes. Thirdly, tools and equipment. Electricians have access to specialized tools and equipment that are necessary for diagnosing and repairing electrical problems. These tools include multimeters, wire tracers, circuit testers, and other diagnostic equipment. Fourthly, code compliance. Electricians are familiar with the National Electrical Code, NEC, and other applicable codes and regulations. They can ensure that electrical work is performed in compliance with these codes, which is essential for safety and legal compliance. When consulting with an electrician, be prepared to provide them with as much information as possible about the problem. This includes a description of the symptoms when the problem occurs and any troubleshooting steps that you have already taken. An electrician will typically start by inspecting the electrical system and performing diagnostic tests to identify the source of the problem. Once the problem has been identified, they will recommend a course of action to repair it. It is important to follow the electrician's recommendations and to have the repairs performed by a qualified professional. Attempting to repair complex electrical problems yourself can be dangerous and can potentially lead to further damage or injury. Some situations where it is particularly important to consult with an electrician. Firstly, persistent electrical problems. If you have tried basic troubleshooting steps and the problem persists, it is likely that there is a more complex underlying issue that requires the expertise of an electrician. Secondly, unfamiliar electrical work. If you are not familiar with electrical work, it is best to leave it to the professionals. Attempting to perform electrical work without the proper knowledge and training can be dangerous. Thirdly, code violations. If you suspect that there may be code violations in your electrical system, it is important to have an electrician inspect the system and make any necessary repairs. Fourthly, safety concerns. If you have any safety concerns about your electrical system, such as flickering lights, sparking outlets, or burning smells, it is important to consult with an electrician immediately. In summary, consulting with a qualified electrician is recommended when troubleshooting persistent electrical issues. Electricians have the knowledge, experience, and tools to diagnose and repair complex electrical problems safely and effectively.